What up? We got our soft closure beard going on. Woo! So just doing a video to help you with this new crazy stuff, probability of condition and union guided notes and homework assignments. So this first one we did in class, which was 12 face cards minus 2, so 10. Out of 52 minus 2 face cards minus 1 face card, so 10 out of 49. Nice. Then we learned this. And so this is a new kind of probability. So this is called, this has the word given in it, so that's your key indicator there. So this is called union, or so given, not union, sorry, conditional. So given indicates that we are doing a conditional problem, basically. Yeah. So then, let's see here. So given means that we're doing, that this is a conditional type of problem. And so with conditional, you have to use like a formula. And so with conditional probability, given that something's happened, what's the probability of something else happening? So when 2 fair dice are rolled, again, we mean 6-sided dice. 6-sided dice. So when 2 fair 6-sided dice are rolled, what is probably getting a sum of 7, given that the first die roll is an even number. Okay, I think the homework assignment says odd number, but the process is basically the same because they both have the same count. And I'll show you what I mean. So again, conditional is the probability of A given B, right? So that little dash there is stands for the word given. Equals, now here it is, so the probability of A and B happening, right? The probability of A and B happening. So this symbol there, so that just means the word and. So both events happening at the same time, basically. It's also called the intersection. And then divided by the given. And so whatever the given is, it needs to go in the bottom. We basically need to subtract it off or divide it off because we know it's already happened. So that'll help improve our chances by dividing off the given because we know that it's already happened. So in this case, with this problem, we're looking for the probability of getting a sum of 7, given that the first die roll is an even number. Okay, so we're basically doing this event. This goes on top. So the probability of 2 dice, right, summing to 7, and that's that symbol right there, and the first die roll out of the 2 dice needs to make sure, in this case, that first die roll needs to be even. And so we're going to go and find the intersection, basically, of both of those events happening at the same time, right? And so how we do that is we go ahead and count all those ways. And since we're trying to sum to 7, we're going to kind of look at how we could sum to 7 with 2 dice, given that the first die roll is even. So 1, oops, that's odd. So let's see here. So the first die roll has to be even, so 2 or 4 or 6. Now if you think about it, on the homework, this problem changes slightly on problem number 1. And how it changes slightly is instead of saying the even numbers, it's actually going to ask for the odd numbers for this place right here. And so it's going to be exactly the same situation, so we're kind of doing the homework at the same time. In fact, I think the answers are exactly the same as the guided notes on that first problem anyways, not the second, but definitely the first. And so odd would be 1, 3, and 5. You're still basically counting these ways. Okay, so then what does the second dice have to be just to make sure this works, make sure it's valid? Because sometimes it's not. Like on the second problem in the homework, you're going to probably cross out the last one. In this case, we won't cross that out there because we can still add to 7 with 2, 4, and 6 because it's going to be 5 and 3 and 1. And so nice. So there are going to be 1, 2, 3 ways for this event to happen. But since we're talking about the probability, it's not just 3 ways. It's 3. Probability means out of your total, right? Out of what you want. And so it's 3 ways out of all the total ways of rolling 2 dice. And all the ways of rolling 2 dice are, remember, 6 times 6. There's 6 ways for the first dice, 6 ways for the second dice. So 3 ways out of 36 ways. Nice. So now to finish, and that's the same with this one, because this will be what? 1 and 6, 3 and 4, 5 and 2, equals 7, equals 7, equals 7. And so again, there's going to be the same exact thing here on the homework. So 3 ways. So 3 ways out of 36. Now divided by, you have to do the probability of the given, right? Probability of the given. And so probability of the given, well, it says here that, let me make sure this is recording, because that'd be bad if it wasn't. Yeah, it is. Phew. So probability of the given. So given the first die roll is an even number. So what's the probability it's an even number? Probability it's an even number would be like there's 3 odd numbers out of 6 total numbers. Shout out to Alexis, that's what she said. Nice. So 3 out of 6, good. So then we could just flip and multiply to finally solve this problem. So to solve this problem now, we'll go ahead and use lime green. Whoa! And so we're going to multiply by 6 over 3. And the reason why is we're flipping and multiplying. So you can't have a fraction over a fraction. So we're flipping, multiplying. And so that'll get rid of the 3's, because 3 divided by 3 is 1. 6 divided by 6 is 1. So that just goes away on the bottom. And then over here, the 3's are going to cancel, leaving us with just 6 out of 36. Nice. Now, I don't see 6 out of 36 here, but maybe one of these reduces to that. I'm thinking it's probably this one, because 3 out of 18 reduces to 1 6, and 6 out of 36 reduces to 1 6. So that must be the right answer. Nice. I'm going to pause this for a second. And we're back. So again, our answer there is going to be 1 out of 6, or 3 out of 18. I think I've seen a 3 out of 18 on a statistics AP Stats test. And the reason why, I believe, is because basically they were doing, I'm trying to remember now. So it was because, because they're saying like 18 out of 36 here instead of 3 out of 6. You know, half of the 36 dice were like the first dice roll was even. So then you just cancel the 36s and you're left with 3 over 18, which is the same thing as 1 over 6. Nice. Cool. So then for the homework assignments, down here there's that same problem, and this time 3 out of 18 does reduce you up to 1 6. And then question number 2 is saying something to 5, and first die roll is odd. And so the trick there with that one is that it's going to be what? It's going to be just 1. So the first die roll is odd, so 1 3 5. But then when you're trying to sum to 5, that bottom number can't be 5, because 5 plus 1 or plus anything is not, because remember there's 2 dice we're dealing with now. And so yeah, so that's not going to work with this one. But the other ones will definitely work. It'll be what, a 4 and a 2. So this way will be 2 out of 36. and then divide it off the given, which is being an odd number, which is 1/2 or 3/6. And then you can flip and multiply. Wait a sec. That looks unusual. So 2 ways out of 36. Good, 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 good. Let's not say 1/2, even though it is. Because it might. Oh, no, yeah, that's right, that's right. And then we can flip and multiply. 2/1, 2/1. And when we flip and multiply 2/1, then we get 2 times 2 is 4. And then over 36. And so I'll let you reduce it to see which one of these answers it is. It is definitely one of those answers. Cool. Okay, the next one is the fridge problem. This one actually is a lot easier than you think. So the fridge problem, they give you the and on top. And the given goes on the bottom. And so the and, here it is the 0.04. And then the given, new fridge damage during delivery, is 0.10. And so it's just 0.04 divided by 0.10. So that problem is really easy. Very nice, very nice. Hopefully you can figure out which one it might be. And then number 4 is the union problem. And so union is a little bit different than conditional, right? And so the union problem is basically like this. How do you know it's union? It has at least one of these two pursuits. So at a certain high school, 1/6 of all students take stats. 1/4 of all students play football. These two events are independent. If a student is chosen at random from the school, what's the probability the student is involved in at least one of these two events? So we're gonna go in and pick up somebody out of the school randomly. We're gonna go in and grab them with the claw. Grab them with the claw. Pick them up. And so what's the probability that we pick up that student that it's either a stats or a football player or both? And so how that works is, here's our formula here. So it's the probability of A union B equals the probability of A plus, plus the probability of event B. And then because we're adding the intersection twice, technically, when we do this, we need to minus off that intersection once. And so when we say intersection A intersect B, so we're actually just saying to minus off the probability of A times the probability of B. Nice, not too bad, not too bad. So this is a union probability problem. And so we have a 1/6 of all students take statistics, and 1/4 of all students are football players. And then the intersection of that is 1/6 times 1/4. And so 1/6 times 1/4 is just 1/24, right? Nice, nice. And then you can turn these into 24ths by multiplying the top and bottom by 4, multiplying the top and bottom by 6, and now we have a common denominator, right? So we have 4/24 plus 6/24 minus 1/24. And so 4 plus 6 is 10, and 10 minus 1 is 9. So we get 9/24. We got to figure out what that reduces to, right? So I'll let you reduce it and see which answer it is when you reduce that. Beautiful. Which one is it? Reduce it. Reduce your answer. There we go. Okay, so then the next one is a dice one again. And then the insurance one. So really quickly, all you have to do technically on the insurance one is, because it's just asking for one or the other or both, because it says the word at least. But they're just asking for both. And so both means the probability of A and the probability of B, because it's asking for both. Didn't mean to cross that out there. And so when we say A, the probability of A and B, we're actually saying the probability of A times the probability of B And so for this particular problem, you can just multiply. So 0.68 times 0.44. And that'll give you the right answer. Sick. Okay, last but not least, I can see something flying past like a hawk trying to eat my ducks or something. Okay, last but not least is this one. And so this final problem will help you with the setup and you do the calculations. And so basically we want upperclassmen who ride the bus. And so we're going to grab our total upperclassmen, which is 515. And we're going to times it with the percentage of upperclassmen who ride the bus. Remember to move it 2 decimal places. So 0.679. And so there you go. That's what we want. We want upperclassmen who ride the bus. And then divided by upperclassmen who ride the bus. Plus underclassmen. Plus underclassmen, which there are 652 of them. So plus underclassmen who ride the bus. And how do we make it who rides the bus? We multiply by their percentage, 0.829. So carefully do the bottom and then divide the top by that bottom and you'll get your right answer. Woo! Thanks for watching. You behind the screen. Thanks for watching. Thanks for watching. Statistics, drugs. Woo!